In this video, we're going to take a look at exam revision for circles. So what we're going to do here is work through some exam style questions based on circles and everything we've covered so far for the first year material on circles. So like always, pause the video as we work through these questions, do have a go yourself and see if your solution matches what we get on the screen. Other than that, I think that's everything we need to get started, so let's take a look now at the very first question. So if we start by taking a look at question 1 here, what we've been given is the circle C, and we can see the equation of the circle C here. Now for part A, we have to show that the point 0, 7 lies on the circle C. Now if this point here, 0, 7, lies on the circle C, then when I substitute that point into my equation here for the circle, then we should find that the left-hand side here, when I substitute 0, 7 in, is equal to 40. Okay, so let's substitute that point in and see what we get on the left-hand side. We're going to do 0 plus 2 squared, so 0 plus 2 all squared. And then we've got plus, so it's y minus 1 all squared. Okay, so that's going to be plus 7 minus 1 all squared. And we should get that this is equal to 40. So if we simplify this here, 0 plus 2, that's going to be 2, so I get 2 squared. Plus 7 minus 1, so 7 minus 1 is 6. I'm going to do 2 squared plus 6 squared here. Well, 2 squared would be 4. 6 squared would be 36, so I get 4 plus 36, which is equal to 40. And therefore, because the left-hand side here, when I substitute 0, 7 in, is equal to the right-hand side, then we can see that the point 0, 7 must lie on the circle C. Okay, so therefore, 0, 7 lies on C. Okay, so that's all we need for part A. Hopefully nice and straightforward. Now for part B, we have to find the coordinates of the points where the circle C meets the x-axis. Now, if we think about what's happening here, when it meets the x-axis, that would be when y is equal to 0. Okay, it meets the x-axis and y is equal to 0. Okay, so what I'm going to do here is I'm going to substitute y equals 0 into my equation here for the circle C, and then let's see if we can solve. So I'm going to get x plus 2 all squared, x plus 2 all squared. Then I've got 0 minus 1 all squared. Okay, so plus 0, because that's when y is equal to 0, so 0 minus 1 all squared, and that's going to be equal to 40. Okay, now what I need to do here is simplify. So I'll keep the bracket as it is here, so x plus 2 all squared. Okay, keep it like that. 0 minus 1, so that's going to be minus 1 squared, which will give me positive 1. So I get plus 1 here is equal to 40. But now we just need to solve, or basically just rearrange to make x a subject here. We're just solving for x. So in that case, I'm going to subtract 1 off both sides here. It's going to give me x plus 2 all squared. That's going to be equal to 39. Now here, what I'm going to do is I'm going to square root both sides. And remember, we also need the negative solution. Okay. So if I square root both sides here, on the left-hand side, we'll just get x plus 2. On the right-hand side here, then, we're going to get the positive and negative solution here, the positive and negative square root, I should say, of 39. So in that case, then, if we just want x here, I just need to subtract 2 off both sides. So therefore, x is going to be equal to minus 2 plus or minus the square root 39. Okay. So in that case, then we can clearly see our coordinates here. I'm going to get minus 2 plus the square root of 39. And clearly the other point will be 0. Obviously this occurs when y is equal to 0, or it meets the x-axis when y is equal to 0. And then the other point here will be minus 2 minus the square root of 39. Okay. And there we have it. So that's our solution to A and to B, and that gives us the solution to question 1 overall. Moving on to question 2 now, we've been given the points A and B here. So A has coordinates minus 2, minus 4, and B has coordinates 6, 2. Now we're told that these points here lie on the circumference of the circle C. Now we're given that AB is the diameter of the circle C, and we're asked to find an equation for the circle C. So how do we do this here? Well, let's just think about maybe sketching this problem here. So let's do it over here, with my y-axis, and this will be my x-axis here. Okay, so x-axis and y-axis. Now, I've got the points here, minus 2, minus 4. So let's say minus 2, minus 4 is there. Okay, so that's A. And then we've got B here, which is 6, 2. Okay, and let's say that's there. Okay, now these form the diameter of the circle C. Okay, so imagine if I join these up here, That's the diameter of this circle. Okay, I won't try and draw the circle. I might be a little bit off because I'm doing it on a tablet. It's not the easiest to draw. But that's the idea. We've got a circle going around here. Okay. Now I need to find the equation of this circle here. So I need two things for this. I need the center of the circle, which in this case will actually be the midpoint of this diameter. Okay, so we need to find the midpoint of this diameter. And then we need to find the distance from one of these points here, A or B, to the midpoint here of this line, which would be the center of the circle. Okay, so let's start by finding the midpoint. So for the midpoint here, we're finding the midpoint of this straight line here. So I'm going to average the x coordinates. Obviously, just do the same then with the y coordinates. So the midpoint here will be equal to -2 plus 6 divided by 2. -2 plus 6 divided by 2. And then it's going to be -4 plus 2. -4 plus 2. Again, we just average that, so divided by 2. Okay. So in this case, what would we get here? So 6 minus 2 is 4. Divide that by 2, I'm going to get 2 there. And do the same here. So -4 plus 2 is the same as 2 minus 4. So I get -2. Divide that by 2, I'm going to get -1. Okay. So what I can see here then is my midpoint here is 2 minus 1. So let's just say that's there. Okay, obviously my line's not perfect, so my sketch isn't perfect, but you get the idea. 2 minus 1. And now what I need is the distance here from either A or B, or the distance, sorry, from A to C, if I call this C here, or from C to B. Okay, because what this would give me then is the radius. Okay, so we now need the radius here. And to find the radius, like we said, we're just going to find the distance then from A to C or from C to B. It doesn't matter which one you choose. It's completely up to you. Okay. Now, seeing as B here is positive coordinates, so that's 6, 2. I'm going to use B here. It might make the calculations a little bit more simple. But in that case, then we just need to apply the distance formula here. So in that case, the radius here is going to be the square root of, I'm going to do 6 minus 2 here. So subtract the x coordinates. So 6 minus 2. We need to square that here. Then I'm going to do 2 minus -1 here. So plus 2 minus -1. Obviously, just take care here with the brackets and the negative of a negative. So in that case then, we're going to get the square root of 6 minus 2 squared. So that's going to be 4 squared. So that's going to be 16. I then do 2 minus -1. So that's going to be 3. So that's going to be 3 squared, which is 9. I get the square root of 16 plus 9, which would give me the square root of 25, which in this case is going to give me 5. Okay. So what I know then, the length from here to here, this radius is 5 units. Okay. So in that case, then we need to put all of this together now and we can form the equation for the circle C. So if I present it in the form of x minus a all squared plus y minus b all squared is equal to r squared. So in that case then, I'm going to get x. So this is my midpoint here, the center of the circle. So that's going to be x minus 2. Remember, we take the opposite sign here. So if that's positive 2 here, we take that as x minus 2. We square that. Then it's going to be y plus 1 in this case because it's minus 1 here. So plus y plus 1 all squared. And this is equal to r squared. So if the radius here is 5, I need to square this here to get my r squared. So in that case, it's going to be equal to 25. Okay. Now, just a note here, you can also present the equation of the circle here, C, in a different form. Obviously, if you was to expand all of this here and have it in the form where it's something like x squared plus, say, ax plus y squared plus by, and that's equal to r squared. You could also have that, for example. That's absolutely fine as well. But I'm presenting my solution like this. I think that's the easiest way to do it, rather than wasting time, obviously, expanding this. But you could also present the equation in that form as well. Okay, but just so you're aware of that, either way, that would give us our solution there to question 2. Moving on to question 3 here, where we've been given a circle which has this equation here. We're told that it has center C and radius r. Now for part A, we're asked to find the coordinates of C. So we're just asked to find the coordinates of the center of this circle. So how do we do that here? Well, what I need to do is take this equation of the circle here and just convert that into this form here of x minus a all squared plus y minus b all squared is equal to r squared. Okay, we need to put it in that form basically, because once you get into that form, you can easily identify the coordinates of the center of the circle and the value of the radius there. So how do we convert it into this form then? That's the question here. Well, remember, to do that, if we've got it in this form here, all I need to do first is group the variable x together, then group the variable y together, and complete the square on each variable separately. Okay, if we group the x's together here, I'm going to get x squared plus 10x, so plus 10x. We then got y squared here minus 6y, so y squared minus 6y, and then don't forget the minus 2 here, and that's all equal to 0. Now from here, like we said, we're just going to complete the square individually. So complete the square on the x part first. In that case, we're going to get x plus 5. Square this here and subtract this value squared. Okay, so subtract this value squared, so that would be minus 25. Now do the same here for the y, or the variable y here. So in that case, I'm going to get y minus 3 all squared. We now subtract this value squared, so that would be minus 9. And don't forget the minus 2 here, and again, this is all equal to 0. Now, all I need to do here is simplify the left-hand side, so in that case, we're going to get x plus 5 all squared. We then got y minus 3 all squared. And then finally, minus 25 minus 9. So that would give me minus 34 there. Subtract another 2, and that would give me minus 36. Okay. Now, what I want to do then is put it into this form here, so I need to add now 36 to both sides. In that case, I'm going to get that this is equal to 36. Okay. And from here now, we can easily identify the coordinates of the center of this circle, which we're calling C here. So that's the center. We can actually find the value of R. So A and B, we technically do those together for this question. In that case then, C here, well, for the x coordinate of the center, remember we take the opposite sign here. So if it's x plus 5, or x coordinate for the center will be minus 5. And then for the y coordinate, again, just like we did with the x coordinate here, we take the opposite sign. So if this is y minus 3, or y coordinate will be positive 3. Okay. So that's part A, that's the coordinates of the center. We now also want the value of R, so that's the radius for the circle. And in this case here, for B, the value of R would be the square root of this right-hand side here. Okay, so this is R squared. I just want R, so I just need to square root that value. So R squared is 36. So in that case then, R is equal here, the square root of 36, giving me 6. Okay, that's our solution to A and B. So now let's take a look at C here. We're given that the circle intersects with the y-axis at the points P and Q. So we have to find the coordinates of the points P and Q. Now straight away, as soon as we see this point here where it intersects with the y-axis, remember, that means x is equal to 0. So pretty similar to what we did for the first question for part B. But obviously for that one we were looking where it intersected with the x-axis. This time now we're looking where it intersects with the y-axis. So again, all I'm going to do is I'm going to substitute x equals 0 into the equation of the circle here, and then just solve for y. So I'm going to get 0 plus 5 squared, 0 plus 5 squared, plus y minus 3 squared, and that's all equal to 36. Okay, so if we simplify here, I'm going to get 5 squared, so that's 25, plus y minus 3 squared, and that's equal to 36. So what have we got here now? Well, what I'm going to do is I'm going to subtract 25 off both sides because we're looking to solve for y here. Okay. And what I'm also going to do is I'm just going to get rid of the line above here. Okay, so I don't confuse, as well as our solution to part B. Okay, just so we've got enough room here to finish part C. Okay, so subtract 25 off both sides. So I'm going to get y minus 3 all squared is equal to 36 minus 25. So 36 minus 25 there, that would give me 11. And now obviously we just need to solve here for y, so I'm going to square root both sides here. So in that case, I'm going to get y minus 3 on the left-hand side. On the right-hand side here, obviously we're just going to take the square root of 11, but remember we do need the negative solution as well. So we're going to get plus or minus the square root of 11. And in that case, if we just want y here, we just need to add 3 to both sides. So y is equal to 3 plus or minus the square root of 11. Okay, so from here now we can easily identify the coordinates, the points P and Q. So in that case then, if we do underneath P here, let's just say P is the first one, and that would be 3 minus, or 3, sorry, that's our y coordinate, so it'd be 0, get it the wrong way around, so 0, 3 minus the square root of 11, and then for Q, that would again be 0, but this time it would be 3 plus root 11. So 3 plus root 11. Okay, so just make sure you put it in the right coordinate. Obviously, this is our y equals, so that'll be your y coordinate. So don't make that mistake that I nearly made there. Make sure obviously you're paying attention. But there we have it. So that's our coordinates for the points P and Q. And that gives us the solution to question 3. Taking a look at question 4 here then, where we've been given the circle C, and we can see the equation of the circle here. Now for part A, we have to find the coordinates of the centre of the circle. So for the centre here, quite a nice straightforward part to this question here, because it's already in this form where we can easily identify the centre and the length of the radius. So A and B here are hopefully nice and straightforward. So for the centre then, well, for my x coordinate, it's going to be the opposite to this -1 here. So if this is -1, my x coordinate will be +1. We do the same then with the y coordinate. So if this is -3, my y coordinate here for the centre will be +3. Okay. Remember, it's always the opposite to this. If this was +1, it would be -1. If that was +3, it would be -3. Okay, so that gives the centre of C there for part A. And then for B here, we have to state the exact value of the length of the radius. Now this is in the form here of x minus a all squared plus y minus b all squared. And that's equal to r squared. Okay, so in that case, then what I can see here is r squared is equal to 10. R squared is equal to 10. So if I want r here, the exact value of the length of the radius, I need to square root both sides. In that case then, r is equal to the square root of 10. Okay, I can't simplify that surd any further. I can't write it as a product of two surds, but one of those surds is a square number. So in that case, we just leave our solution here for the exact value of the length of the radius as a square root of 10. Okay, so that's our solution to B. And then for C here, we have to find an equation of the tangent to C at the point 2, 6, giving your answer in the form ax plus by plus c equals 0, where a, b, and c are integers to be found. Now it's up to you whether you do a sketch to kind of illustrate this problem. Completely up to you. We can try and do a sketch here just to see what we're looking at. Let's have a look at this. So that's my x-axis there. This is my y-axis. Now our centre here is 1, 3. Okay, so we're going to go 1 along, 3 up. Okay, so let's just say my centre is there. Now I'm not sure whether this intersects with the x-axis and the y-axis here. Okay, so I'm just going to draw a sketch. Could be off slightly, but I'm just going to say that's my circle here. Okay. Now what we're told is we have a tangent here, or we're asked to find an equation of the tangent to C at the point 2, 6. Okay, so if I go 2 along and then 6 up, let's just say that's there. Okay, so I'm looking for this tangent here. Okay, not perfect, but that's what we're looking for here. So where do we begin here? Well, what I need to start with then is to find this gradient here. Okay, from the center to this point here of 2, 6. Okay, so this would be my center here, which is 1, 3. We find the gradient here. This should hopefully be nice and straightforward. I'm going to do 6 minus 3. So 6 minus 3 all over 2 minus 1. Okay. So I'm going to get in that case 3 over 1, giving me 3 there. Okay, so the gradient of this line segment here from the center to this point here on the circumference of the circle, that gradient is 3. Now for my tangent here, that gradient will be perpendicular. It's perpendicular to the circle here where they meet. Okay. In that case, we need the perpendicular gradient. The perpendicular gradient, which in this case will be the negative reciprocal of our original gradient. Okay, so in that case, we're going to get minus a third there. And clearly that's what we'd expect from our sketch here, and this is why a sketch does help. We would expect a negative gradient. Okay, if we were to get a positive gradient here, then we'd have to go back, double check it, something that has probably gone wrong. Okay. So what we've got now is the gradient of this line here. we've got a point that it passes through. So in that case, then we just need to use the equation of a straight line. Okay, so what we're going to do now, just box that off. I'm going to change my pen color just to highlight this. So using y minus y1 is equal to m lots of x minus x1. Okay. Well, obviously my x1 and my y1 will be the coordinates of this point here, which this line passes through. I'm now going to do y minus 6, because my y1 is this y coordinate here. That's going to be equal to minus 1 over 3. That's the gradient here of this line of x minus x1, where my x1 here is the x coordinate of this point. It's going to be x minus 2. What I'm going to do here now is get rid of this fraction. Obviously, we want to give our solution here in this form, ax plus by plus c equals 0, where a, b, and c are all integers. But in that case, if I times through by 3 here, take the solution up here, I'm going to get 3y. I get 3y minus 18 is equal to minus x minus 2 there. Okay, so all I've done there from this line to this line here, just times through by the 3 here, get rid of that fraction. Obviously, I'm going to get minus 1 lot of x minus 2. So if we expand the bracket here on the right hand side, obviously the left hand side stays the same, so I get 3y minus 18 is going to be equal to minus x, positive 2 now, so minus minus 2 gives me plus 2, so just be careful for that. We want to give the solution here in this form, so ax plus by plus c equals 0. So all I'm going to do now is add x to both sides and subtract 2. So in that case, I'm going to get x plus 3y, and then subtract 2 off both sides. So minus 18 minus 2 give me minus 20 there. Okay, and that will all be equal to 0, and that gives us our solution there. So in that case, a here will be 1, and the coefficient of x is 1. So a is 1. B here is the coefficient of y, which in this case will be 3. And then c is this constant at the end here, which is minus 20. Okay, and there we have it. So that's our solution to question 4. And finally, let's take a look at question 5 here to finish with. So we've been given the circle C, which has this equation here. And for part A, we have to show that the line y equals 3x minus 3 meets C at 2 points. Because we're looking to show that this straight line here meets the circle at 2 points, we're going to need to use the discriminant to show that. So delta here is equal to b squared minus 4ac. So don't forget, this is just the formula here for the discriminant. And what I'm going to do then is I'm going to take the equation of the straight line here, and I'm going to substitute that into the equation of this circle. Okay, and because it's already in the form here where y is the subject, we can just go straight ahead with that substitution. So I'm going to get x minus 3 all squared plus, so now where we have a y here, I'm replacing that with 3x minus 3. We get 3x minus 3. Don't forget the plus 4 here. Plus 4, and that's all squared. And that's equal to 20. Okay. So what I'm going to do here is I'm going to clean this bracket up. So I've got x minus 3 all squared. That doesn't change yet. We haven't simplified that yet. 3x minus 3 plus 4, that's going to give me 3x plus 1. I get 3x plus 1 all squared. And that's equal to 20. Okay. So let's start expanding these brackets here. So x minus 3 all squared, I'm going to get x squared. I'd get minus 3x and I get another minus 3x. I'm going to get minus 6x there in total. And I'm going to get plus 9. But then I'm going to do 3x times 3x. That's going to give me 9x squared. Plus 9x squared here. We're then going to get 3x times 1, so that'd be 3x. And we're going to get another 3x times 1. So I'm going to get 6x there. Plus 6x. And then finally, 1 times 1 giving me 1. Okay, and this is all equal to 20. What we need to do now is just clean this up here. So I've got x squared plus 9x squared. So that would give me 10x squared there. We get 10x squared. I've got minus 6x here, plus 6x, they just cancel. That would be 0x. I've then got 9 plus 1, so that would be 10. But what I want to do is I want to set this quadratic here equal to 0. Okay, so in that case then, I'm going to get 10 here, minus 20, and that would give me minus 10. Okay, so I get 10x squared minus 10, and that's going to be equal to 0. Okay. So from here then, what I'm going to do now is just basically use the discriminant here on this quadratic. We can just divide through by 10 here to simplify this. So I'm going to get x squared minus 1 is equal to 0. Okay, we can divide through by 10 because there's a multiple of 10 here with the x squared and this constant term. So I get x squared minus 1 equals 0. So now we apply the discriminant to this quadratic here. In that case then, I'm going to do b squared here. Now my b here would be 0. Okay, that would be the bx term. Obviously, there's no bx term here. It's just 0x. So that's going to be 0 squared. So just 0 minus, so we now do 4 times a. So a is 1 here. And then we times that by c, which is this minus 1. Okay, so I would now do minus 4 times 1 times minus 1. What it would give me here is minus 4, which would be positive 4. Okay, so remember, if the discriminant is greater than 0, this shows that there is 2 points of intersection. Okay, so therefore, the discriminant here is greater than 0. So in that case, we have 2 points of intersection. Okay, so quite a bit of work really, just to show part A. But there we have it. So 2 points of intersection. So that's part A done. Now for part B it says hence or otherwise find the coordinates of the points of intersection. Now like we can see here, this is our quadratic that we're working with. So I've got x squared minus 1 is equal to 0. Hopefully nice and straightforward to work with here now. Or hopefully you recognise this is the difference of 2 squares. So I can factorise this. I'm going to get x minus 1 times x plus 1. Okay, that gives me my 2x solutions here. Clearly one of my solutions will be x equals minus 1. My other solution will be x equals positive 1. Okay. Now from here we need the respective y solutions as well. So when x equals minus 1, I now just need to substitute that into this line here. Okay. I mean, you could substitute that back into the equation of the circle here, but it's far more work. It obviously just makes sense to just substitute that into this equation here. So y will be equal to 3 lots of x, so 3 lots of minus 1 minus 3. So I'm going to get 3 lots of minus 1, which is minus 3, minus another 3, and I'll get minus 6 there. Okay. So my first solution there is minus 1 minus 6. We now need to do the same then when x is 1. So when x equals 1 there, we just repeat this again, then y will be equal to 3 lots of 1. So 3 lots of 1 and then minus the 3. Well, 3 lots of 1 is 3, minus 3 would just give me 0. Okay, so our solutions then for part B, or the coordinates of the points of intersection, will be, so we had minus 1 minus 6, minus 1 minus 6, and we also have 1 and 0. Okay, that would be the coordinates of the points of intersection. So coordinates that's the coordinates of points of intersection. Okay, so there we have it. So that's our solution to part B. Okay. What we're going to do now is we're just going to clear the screen because part A and B have pretty much took up the full screen. So we'll just clear that. Do take a note if you don't already have these. We will need these coordinates now for C and D here. So we'll just quickly clear that. So we'll clear that dead quick. So I had minus 1 minus 6, minus 1 minus 6, and 1 0. Okay. That were the coordinates of the points of intersection. Okay, now for part C, it says given that the points of intersection are labelled as P and Q, find an equation of the perpendicular bisector of PQ. Okay, so I'm going to call this P, I'm going to call this Q here. It doesn't really matter which one you call which, let's just label them for now. So it's up to you whether you do a sketch here, or whether you go straight ahead with just finding the equation of the perpendicular bisector. So let's begin with here. If we just think about this, let's just do a quick sketch. Okay, it might not be perfect, but just so we can see what we're looking at. So my circle here, that would have centre of 3 minus 4. So 3 minus 4. So if I have a quick go at sketching this here, It'll be far from perfect, but just so we can see what we're looking at. So that's my x-axis, this is my y-axis. So 3 minus 4. I'll go 3 along, down 4, and we'll say that's our centre there. Okay. And let's just say, again, I don't know whether it quite cuts through the y-axis and the x-axis here, but let's just say it looks, say, something like that. Okay. That's supposed to be the centre. Okay, so that would be 3 minus 4. And we're told that the straight line here, 3x minus 3, meets C at 2 points. So if I say this is the straight line here of 3x minus 3, okay, so this is y equals 3x minus 3. Okay, that's my circle. This is my straight line here, and we can see it meets the circle here at 2 points. Let's call that the point P there, and that the point Q. Okay, what we're looking for here is the equation of the perpendicular bisector of PQ. So it would be halfway between PQ here, and it will cut through like so. Okay, so it would be in my perpendicular bisector, and we're looking for the equation of that line. So clearly the first thing we need here is the midpoint of that line segment PQ. Okay, so from P to Q. Okay, so the midpoint of PQ. The midpoint of PQ here, whenever we just average the x coordinates, average the y coordinates. So minus 1 plus 1, divide that by 2. So minus 1 plus 1, divide it by 2. Do the same then with the y coordinates. So minus 6 plus 0. Minus 6 plus 0 again, divide that by 2. So in this case then what I'm going to get here, minus 1 plus 1, that's going to give me 0 over 2. So that would be 0. I'm going to get 0 there for the x coordinate. And for the y coordinate, then it's going to be minus 6 plus 0, so that's minus 6 divided by 2. I'm going to get minus 3. Okay, so you can see that my diagram isn't perfect because clearly this x coordinate isn't 0, but we'll just use it for, like I said, the purpose of kind of illustrating the problem. So that's the midpoint of PQ. Okay, so we get 0 minus 3. Now, remember with the perpendicular bisector of a chord like this here, the perpendicular bisector will always cut through the centre. Okay, so this is my centre here, which had coordinates 3 minus 4. But what I know is I know a point where my perpendicular bisector will cut through, and we also know the midpoint here. Okay, so we also need to work out now the gradient. Okay, so for the gradient here, running out of room a little bit again. Let's do that above here. So for the gradient M, remember we can just work out the gradient from this point here, the midpoint of PQ, to this point here at the center. Okay, so midpoint here is 0, 3, center is 3 minus 4. So I'm going to do minus 4 minus 3. That's my y2 minus y1. And I'm going to do x2, so that's 3 minus x1, which is 0. Okay. So what we're going to get here, so I'm going to get minus 4 minus 3. So that's the same as adding. So I'm going to get minus 4 plus 3. That's going to give me minus 1. And I do 3 minus 0, giving me 3. Okay, so I get minus 1 over 3. And clearly we'd expect that here. This is a negative gradient, so that's absolutely fine. So from here then, we just need to substitute that into the straight line as well. Now let's just thought about it. Obviously we didn't quite need to actually work out the gradient there because we have this straight line here. So the gradient would be perpendicular to this one. So if that's 3, obviously my perpendicular gradient would be minus a third. So I've kind of done a bit more work than necessary, but again, just showing that kind of idea here. So now we just need to use y minus y1 is equal to m lots of x minus x1. So let's just substitute in our coordinate here for the center. So we're going to get y minus y1. So in this case, my y1 here is minus 4, so that's going to be y plus 4, so minus 4. And that's going to be equal to m here, that's minus a third, times x minus x1, where x1 is 3. Now it doesn't ask for this in a specific form, so what I'm going to do here is I'm just going to put this in the form y equals mx plus c. Okay, so y equals mx plus c. So expand the right hand side here. So the left hand side will be y plus 4. I'm going to get minus a third x, We then do minus a third times minus 3. So a negative number multiplied by another negative, they'll become positive. So I'm going to get plus 1 there. Okay, so minus a third times minus 3, that will give me positive 1. And like I said, if I want it in the form y equals mx plus c here, I just need to subtract 4 off both sides now. Okay, so just so this is clear, subtract 4 off both sides, so I'm going to get y equals minus a third x, and then 1 minus 4, giving me minus 3 there. Okay, again, my diagram really isn't great, because clearly that straight line here, this perpendicular bisector, isn't going to have an intersect there of minus 3, but if you do draw an accurate diagram, you'll be able to see that a lot better. Okay, so that's our solution to C, just so that's clear. So that's the equation of the perpendicular bisector of PQ. And again, we're just going to need to clear the screen here, just so we can actually see part D to finish with. So we do need P and Q here. So minus 1, minus 6, and 1, 0. Okay, so that's P and that's Q. We're asked to show that the distance between these points P and Q is 2 root 10 units. So all we need to do is just find the distance between these 2 points. Okay, so for the distance here between these 2 points, remember this would be the square root of the difference in the x coordinates. It's going to be x2 minus x1 squared plus the difference in the y coordinates again squared. So y2 minus y1 all squared. So putting this in together then, I'm going to do x2, so that's going to be 1 minus minus 1 all squared. So 1 minus minus 1 all squared. Just do take care with the brackets here. And we do y2, that's going to be my y2 here, so 0 minus minus 6 all squared. Okay, putting all this together here. So 1 minus minus 1, so that's the same as 1 plus 1. So I'm going to get 2 squared there. I'm going to get 2 squared there. Here now, I'm going to do 0 minus minus 6. That's the same as 0 plus 6. That's going to give me 6 squared. We get 2 squared plus 6 squared. Okay, so let's just double check that. 1 minus minus 1 is the same as 1 plus 1. We square that, so that's 2 squared. We then do 0 minus minus 6, which is the same as 0 plus 6, giving me 6 squared. If I simplify this here, we're going to get 4 plus 36. So 4 plus 36, which simplifies to give the square root of 40. Okay. Now we're asked to show that the distance here between the points P and Q is 2 root 10 units. So we're a little bit off here, which means that we should hopefully be able to simplify this. So writing this now as a product of 2 surds, where one of those surds can simplify to give a square number here. What I'm going to get then is root 4 root 10. So root 4 times root 10 gives me root 5, but we know root 4 is equal to 2. So what I get here is 2 root 10 as required. So 2 root 10 units as required there. And finally, there we have it. That was quite a long question. I'm surprised I didn't make a mistake, but there we have it. So 2 root 10 units gives a solution to D, and that gives us a solution to question 5 overall, and that brings us to the end of this video on exam revision for circles.